If $12,450 is invested in an account that pays interest compounded continuously, so I'm circling this keyword compounded continuously because we know what formula we'll be using, okay? For compounded continuously cases, we know the ending balance A is equal to principal times e raised to the rate times time power, right? So A equals PERT. That is the formula we will use to solve this problem. So they gave us the principal, like how much is being invested first. So that's our P. Let's see what else they give us, okay? How long will it take to grow to $250,000 at 3.65%? Round to the nearest whole year. So, they're not asking for how much money will I have in the future. They're asking how long do I have to wait to have $250,000. So look, they gave us an ending balance that they want to have. Okay, $250,000. How much is that? $250,000, right? So $250,000 is the ending balance that we want to achieve. P, like we said, is $12,450. And we're multiplying this by this exponential term. So I'll do e raised to the r. The rate they gave us is 3.65%. So if you convert that into a decimal, you get 0.0365. So that's our rate, 0.0365. And we're multiplying this by that unknown t. So we now have to solve this equation, okay? What's the first thing we should do to both sides? Let's divide both sides by 12,450 to cancel that out. Divide this side by 12,450. I have a calculator on my phone that I'm just going to use to divide, okay? So what is this amount divided by 12,450? I got 20.08, blah, 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 like I see a couple more decimal like numbers after it, but I'll just round it to that, okay? And on the right side, that canceled out. So the only thing left is that green exponential term. I'll just copy this down. Now, what do we do to both sides to solve for that t? Well, this is the point we have to take natural log of both sides. So if I take natural log of the left side and the natural log of the right side, the left-hand side will just be natural log of 20.08. And what will happen to the right side? This exponent comes down to the front. So we have 0.0365t. And what happened to this natural log of e? Natural log of e is just 1. So you can say this is getting multiplied by 1, or, it just cancels out. So no more ln e. This is what we have. Now we're going to solve this final line. Give me 1 second. I should make this a little bit smaller. Okay. We're almost done. If I want t by itself, I just need to divide both sides by this decimal. Divide this side by that decimal. So that, this cancels out. And we just have t equals whatever this is, okay? So on your calculator, you type it in. I'm not going to open up a computer calculator. I'll just go ahead and type this on my cell phone calculator, okay? Natural log of 20.08. If I divide it by 0.0365, you should get 82.18 years. So if we wait about 82 years and a little more months, then we will have $250,000 in this situation. They said round to a whole year. 80, if you say 82 years, I mean, if we follow the typical rounding rule, then we will round this down to 82 years, right? But technically speaking, we're not going to have $250,000 after 82 years because it takes 82.18 years. So to have a guaranteed or over $250,000, we will have to wait 83 years, right? You know, I gotta open up that calculator. I'll show you. If I go to Desmo Scientific, and I'll type in this equation, okay? So we start with $12,450, and we multiply this by e raised to the 0.30365 times 82. Now look at that. Is that $250,000? Not quite yet. That is 248,300, and so that's not quite $250,000 yet. But if I wait 83 years, that's gonna be over $250,000. So if you want to have guaranteed over $250,000, then you should wait 83 years. But if you just want to get as close, 82 will be fine. If you put 82 or 83, I'll be happy with either answers, okay? Because both are very good answers. But the exact answer would be 82.18 years, and that gets us really, really close to $250,000, right? So like, because this happened because I rounded in the middle of a problem. But if I try to be super accurate, you know what I'm doing. Like if I want to be like super, super accurate to catch that $250,000, I don't know what I'm doing over here. I'm just playing around, as you can see. But the exact value will be something like that. But 82 or 83 will work just fine, okay?